Hi everyone, welcome to Educate Cloud. This is my first video on A-level maths, so just a little introduction about me. My name's Zainab and I'm an experienced maths tutor and an ex-maths teacher with over 6 years of experience helping students smash their A-levels and GCSE. So I've taught hundreds of students online and spent over 1,000 hours doing one-to-ones and group lessons. So now I really want you guys to feel confident and prepared for your A-level maths paper 1. So in today's video we're going to be going through a predicted paper for EDEXCEL A-level maths paper 1. So this is based on the topics that come up again and again year after year. So it's going to be useful for focused revision, especially if you're really short on time. So we're going to be going through exam style questions on each of these high frequency topics. So I'll walk you through how to approach them, common things to sort of avoid, and then techniques to get those method marks. So we're going to be covering circles, vectors, factor theorem, binomial expansion, sequences and series, especially with sigma notation because that's very likely to come up, proof by contradiction, trig identities, modelling with the r cos theta formula, double angle formulae, and numerical methods including the Newton-Raphson method, locating roots. So these topics, I've selected them because they've popped up consistently in paper 1 over the past few years, so it's really worth making sure that you're really solid on them. So what I do is grab your pen, calculator, and we'll get started on question 1. So this is a question on the screen now and we'll go through it step by step. So it says a circle has the equation x squared plus y squared plus 4x plus 12y is equal to minus 23, and the lines L1 and L2 are both tangents to the circle that intersect at 5, 0. So if you haven't already, try the question, pause it and try, and then we need to find the equations for L1 and also L2. So the first thing we do, like with any sort of like we do with any circle questions, is we need to group the terms and complete the square. So let's do x squared plus y squared plus 4x plus 12y is equal to minus 23. And so let's group and complete the square. X squared plus 4x, we could put that together, and y squared plus 12y, put that together, and that equals to minus 23. Then we can break this down, so we get x plus 2 all squared, take away 4, so remember you square it and take it away if you're completing the square, and then y plus 6 all squared, take away 36, which equals to minus 23. Okay, so you get x plus 2 squared, we can bring over the 4 and 36 and add them onto the minus 23. So what we'll get when we do that is minus 23 plus 40, which is 17. Okay, now we know that the line passes through 5, 0, and so if we were to set up a y equals mx plus c, we know that when our y is 0, our x is 5, so we're going to get 5m plus c, so c is minus 5m, and so our y is y equals mx minus 5m, and now we can sub that in to our original expanded form, because that is going to give us a quadratic. Okay, so that's going to be substituting it into the circle equation, and then using the discriminant, because we know it crosses at one point, so we're going to make the b squared minus 4ac equal to 0. Okay, so we're going to have x squared plus y squared plus 4x plus 12y equals minus 23. We knew that, and we're going to sub in this instead of the y. So x squared plus mx minus 5m squared plus 4x plus 12mx minus 5m equals minus 23. And let's move on to the next, more space. So when we expand and simplify that, what you should have got is x squared plus m squared x squared minus 10mx plus 25m squared plus 4x plus 12mx minus 60m, and that is equal still to minus 23. Okay, so we can group the x squareds together, so we'll have 1 plus m squared, that's part of our x squared. Then for the x we'll have 2m plus 4, so part of the x, and just for our c it's 25m squared minus 60m plus 23 equals 0. Okay, so that is now in a quadratic form, and we can apply the condition for a tangent, which is that the discriminant is equal to 0. So b squared minus 4ac is going to equal to 0. So here our a is 1 plus m squared, our b is 2m plus 4, and our c is 25m squared minus 60m plus 23. So plug that into the discriminant. So b squared is 2m plus 4 all squared minus 4 lots of ac, and that is equal to 0. And so when we solve this, expand and simplify, use it with expand and simplify it, and then plug it into your calculator. So you should get m to be 1/4 or m to be 19/8. So the full line equation, we know that c was minus 5m, and so for our first part it's going to be y is equal to 1/4 x minus 5/4 by plugging in 5, 0. And then for this one, for line 2, it's going to be 19/8x minus 95/8. Okay, 95/8. So they are our two formulas. Okay, so for line 1 and line 2, they are our formulas. Okay, so that is how you go about this question. It is a very tricky one, so if you're not able to get it fully, because it's worth 8 marks, you should be able to get as many of the method marks. You know, there's a single solution for each line, so that's why the discriminant's 0. We've used the circle equation, we've used y equals mx plus c multiple times, so at least if you can't get the whole thing, you can work on getting parts of it. Now this second circles question is a bit more easier, something that you'd find towards the start of an A-level paper. So let's start working through it. Again, pause and try. This one shouldn't be too difficult because you do the exact same thing. So you complete the square. So first let's group the terms. The x's are together, the y's are together. So we can group the terms. So we have x plus 3k all squared minus 9k squared plus y minus k squared minus k squared plus 7 equals 0. So let's simplify that. So x plus 3k all squared plus y minus k all squared is equal to 10k squared minus 7. Okay, so we know straight away from here that the center, it's the negative of the bracket, so minus 3k and plus k. And then for part II, we know that the radius is just going to be the root of 10k squared minus 7. Don't forget that root. Okay, so that's worth 4 marks, and I would say these are 4 marks that you cannot miss in the paper. Okay, question 3 on vectors. Again, quite a difficult question, but it is using skills that you have already done. So firstly, it says relative to a fixed position O, the point A has a position vector 4i minus 3j plus 5k. The point B has a position vector 4i plus 6k. The point C has a position vector minus 16i plus pj plus 10k, where p is a constant. So given that A, B and C lie on a straight line, find the value of p. Okay, so A, let's write it as column vectors. So 4 minus 3, 5. B, it's 0, 4, 6. C, it's minus 16, P, 10. So we know that if we would like to draw A, B and C from a point O, because we know it lies on a straight line, we know that AB is going to be a scalar multiple. CA will be a scalar multiple of AB. So we can say that K lots of BA is equal to CA. Okay? So BA, well, that's going to be the opposite of OB. This is O. And plus OA. So opposite of OB is going to be minus O, minus 4, minus 6, plus the plus of that, which is equal to 4, and then minus 7, and minus 1. Okay? So that is for that, for BA. And to find CA, we are going to do the negative of OC. So that would be 16 minus P minus 10 plus A, which is 4 minus 3, 5. So that will be 20 minus P minus 3 and minus 10 plus 5, so that's minus 5. So now we know that K lots of 4 minus 7 minus 1 is equal to is equal to 20 minus P minus 3 and minus 5. Oh no, sorry guys. So we know that. Okay, so let's continue now. So now that we have that, we know what we can do is we can find the value of P. So k lots of k lots of 4 minus 7 minus 1 is equal to 20 minus 3 minus P minus 5. And so we can set up 3 different equations to work it out. So we know that 4k is equal to 20, so immediately we know that k is 5. Then secondly, we know minus 7k is equal to minus 3 minus p. So we already know k is 5, so that's going to be minus 35 is equal to minus 3 minus p. So p will be equal to 32, which is your answer for this. Okay? Now the next part, it says the line segment of OB is extended to a point D, so that CD is parallel to OA. Okay? So again, O is here, B was let's say here. So now this is extended to a certain point D, such that we know like A was somewhere here, C is somewhere here, such that OA is parallel to CD. This is again quite a tricky one. But again, it's done in a really similar way to part A through scalar multiples. So we know that if firstly, if it's a straight line, this, then OD is some lots of OB. Okay? So we can say OD is, let's say, Z lots of OB. And then if CD is parallel to OA, then CD will be some lots of OA. So again, CD and OA are parallel, there'll be some lots of each other. So we can set up equations to help us do that. Again, so we know that OD from the diagram will be OC plus CD. So OD is OC plus CD. Okay, so we know OD is Z lots of OB. So Z lots of 0, 4, 6 is equal, that's OD, is equal to OC, which we've been given already. It's minus 16. We worked out 32 and 10. And then let's say it's equal to CD, which is some lots of OA. So let's say k lots of OA, which was 4 minus 3, 5. So we can set up equations here. Firstly, we have 0 is equal to minus 16 plus 4k. Secondly, we have 4z is equal to 32 minus 3k. And lastly, we have 6z is equal to 10 plus 5k. So from this, we can work out that k is 4 and z is 5. So once you have that, we know OD is just Z lots of 0, 4, 6. So OD now as a vector is 5 times 0, so 0, 5 times 4, so 20, 5 times 6, so 30. Okay? And to find the magnitude, we need to square and root it. So do 0 squared plus 20 squared plus 30 squared and root that all. So our answer is 10 root 30. Okay? This is quite a difficult question. So if you do need to try it again, go through it again. But that's how you would do it. Okay, this one, again, it's a little bit easier. So here, firstly, AC, if we draw it on here, we know what AB is, we know what BC is. AC is just AB plus BC. So AC is equal to minus 3I minus 4J minus 5K plus I plus J plus 4K. So that is equal to minus 2I minus 3J minus K. Okay, and for part B, we need to show that cos of ABC is 9/10. So here, we need to find the magnitude of AB, AC, and BC, and then use the cosine rule. Okay? So, AC, that is just going to be 2 squared plus 3 squared plus 1 squared rooted. That's the magnitude of AC. The magnitude of AB, again, do it in the same way. And for BC, do it in the exact same way. And then we need to use the cosine formula. So we know that cos of ABC is equal to B squared minus B squared. Sorry, B squared plus C squared minus A squared over 2BC. And so we are going to do B squared, which is 50, plus C squared, which is 18, minus A squared over 2 lots of BC. Okay, and that's going to give us 9 over 10 for cos ABC, and that's what we needed to show. Okay. Okay, so next question. Use the factor theorem to show that x plus 2 is a factor of g of x. So here what we're going to do is we're just going to sub in minus 2 and show that it equals to 0. So when g is minus 2, show that that equals to 0. That shows that it's a factor. Part B, we could just do some polynomial division. So we have x plus 2 on the outside and 4x cubed minus 12x squared minus 15x plus 50 on the inside. So we're just going to see how many x's we could fit into that. So that's going to be 4x squared. So that's going to give us 4x cubed plus 8x squared. Take that away and you get minus 20x squared. So see how many x's fit into that. Well, that's minus 20x. So times that out, you get minus 20x squared minus 40x. And then take that away, so minus 15 minus 40. So that is going to give us 25x. So that fits in 25. And yeah, that's your solution. And now you can realize that this has two square numbers, so we need to find out what it would become in that format. So your answer here would just be x plus 2 and 2x minus 5 all squared, okay? And then for C, we're just showing that g of x is less than or equal to 0. So we are literally solving this equation, and we know that here this is 5 over 2 and this is minus 2. So for part C, x is either less than or equal to minus 2, or x is equal to 2.5. Okay? And for part I, for part I, g of 2x, so that's just going to be this graph, kind of just squeeze like that. So that will be 1.25, and that will be minus 1. So it's just squished. Continue with question 6 in our next video. I hope this was really beneficial for you guys. And I wish you a lot of good luck with your revision. You've got the May half term, you're probably all on study leave as well, so you've got loads and loads of time to do as much beneficial revision and focus on these topics. Obviously don't forget your mechanics and stats, but pure at the moment should be like your main focus. So definitely please work as hard as you possibly can and follow some of the methods and exam tips that I have explained in the video. And if you follow me on my Instagram, I'll be releasing a lot of content relating to A-level maths as well. So yeah, good luck. Bye.